Okay, so we're looking at simultaneous equations. So get a heading down, lesson objectives, and it's the third actually. So get that down, hit pause, get that down. When you're ready, hit play again, and we go into the starter. Right, so here's our starter, 3 questions. Hit pause, have a go. When you're ready, we'll go through the solutions together. So hit pause now. When you're ready, hit play again. Okay, so question 1. The sum of money is shared between friends in the ratio of 5 to 3. 5 to 3, so the total number of shares is going to be 8. Let's just write that down now. 8. If the smaller amount is 120, how much was the total amount? The smaller amount is 3, so that means they're telling us that 3 shares is equal to £120. Now I think about this as, if 3 shares equals 120, I think of this bar method here. If I have £120 is shared equally between 3, that means each one has got to be the same. Got to be 40 each. Or we could just write 1 share. It's going to be equal to 120 divided by 3, which is £40. So 8 shares then, which is the total number of shares, which we know. It's going to be 40 times 8, which is £320. Good question. And now I hope you read that right, and I hope nobody actually, without reading the question properly, tried to share it in a given ratio. You've got to read the question. Right, question 2. X squared plus 2x minus 15 equals 0. We've got to solve that. Now you're very good at this now. So because we have no coefficient of x squared, it's just going to be x times x equals 0. Now let's take that minus 15 and factorize it. Now I can try 1 and 15, but they're too far apart. The difference won't give me 2. So I'll try 3 and 5. Excellent choice, because 5 minus 3 gives me 2. And because it's plus 2, 5 minus 3 works. So we've got minus 3 and plus 5. So that means, that implies that either x minus 3 equals 0 or x plus 5 equals 0, which in turn implies that either x is equal to 3 or x is equal to minus 5. This one, first term, x squared, square term, 81, square number, no middle term. Straight away you can see is dots, difference of 2 squares. So we can factorize that. It's going to be x plus 9 times x minus 9 equals 0. 9 is the square root of 81 and x is the square root of x squared. So this implies then that either x plus 9 equals 0 or x minus 9 equals 0. But one of them has got to be equal to 0, because 0 times something will give you 0. And that in turn implies that either x equals minus 9 or x equals plus 9. Don't forget, you can write it like this: x is equal to plus or minus 9. It saves a bit of space if you write it like that. But that's fine, as is that. And the final starter question, express 160 as a product of prime factors. I'm going to look for my prime numbers: 2, 3, 5, 7, 9 isn't 1, 11, 13, and I can stop there. If I need any more, I'll do that straight after. So 160, let's factorize it. 2 goes into 160, 80 times. I'm circling the 2 because it's a prime number. We'll go again. 2 goes into 80, 40 times. I've circled the 2 because again that's a prime number. We try again. Always trying with the smallest number 2 goes into 40, 20 times. Seems to be quite a few 2's here. Does 2 go into 20? Yes. 10 times. Oops. And again, does 2 go into 10? Yes, 5 times. And they're both, 2 and 5 are both prime numbers. So I can say 160 is equal to 2 to the power of 1, 2, 3, 4, 5 times 5. Good. So mark your work, brag rate it, and when you're ready, well, hit pause and mark it. When you're ready, hit play again. Okay, so simultaneous equations. Let's have a look at 2 equations here. Okay, I do hate that dots tracking. Now, we've got x minus y equals 2 and x plus 2y equals 14. Now, these are 2 straight line equations, and in this one we've got when x equals 2, so if x equals 2, y is also going to be equal to 0, because you have that 2 minus 2 gives you 0. And here, if x equals 0, 2y equals 14, so y is going to be equal to 7. So those are one set of solutions for them. We can have a whole list of solutions for each of them. Now, if we look at these solutions, which you could generate yourselves, there's something about one set of solutions for the first equation and a set of solutions for the second one. And it's those two. When x equals 6, y equals 4, that works for this equation and that equation. Do you have any idea what that means? That solution there is the same as that solution there. If we draw it on a graph, draw this line and that line on a graph, the solution x equals 6, y equals 4, there, the red dot, is where they intersect, and that's the solution of the 2 lines. And that's what we're trying to do with simultaneous equations. We're trying to find a solution where the lines intersect. Okay, you're only going to do straight lines at GCSE, so where the lines intersect, that's what we're trying to find. Now we can draw a graph. Graphical solutions work, but we can also work out where they intersect in another way. And that's what we're going to look at today. Okay. So if we look at these 2 equations here, we can solve them simultaneously. And we're going to look at the elimination method. Now, we always label our equations. X minus y equals 2 is equation 1. X plus 2y equals 14 is equation 2. I'm going to try and solve it. Now, if I have x and y, that means I've got 2 variables and I can't solve it. But because I've got 2 variables in the first equation and 2 variables in the second equation, I can solve it by getting rid of one set of equations. In this case, it would pay me to subtract. Okay, so I can subtract, and I'm going to do it the wrong way around. I'm going to write them again. X plus 2y equals 14, it's equation 2. And x minus y equals 2, equation 1. If I subtract, oops, 1 from 2, then draw a line here. X minus x gives me nothing, which means I get rid of the x, which is what I'm trying to do. 2y minus minus y means 2y plus y, so that's 3y, is equal to, and then I've got 14 minus 2, which is 12. That means if I divide by 3, y is going to be equal to 12 divided by 3, which is 4. So y equals 4. To find x, I just sub this back into either equation. Let's sub it back into equation. You say sub for y in equation 2, in equation 1. And so wherever we got x minus y equals 2. So x minus 4 equals 2. If we float and ping the 4, the minus 4 over the other side, that means that x is going to be equal to 2 plus 4. So that means x is equal to 6. Okay, so that's our solution. No need to write this equation down. That was just a quick explanation for you. We're going to look at another one, and then you can get to write it down. So don't write this one down. Just wait for the next one. Okay. Okay, so this is our first example. 2x plus y equals 21 and x minus y equals 6. First things first, you always label them. I'm hoping this has come back to you, because I remember going through this with you in year 9. So hopefully this is all coming back to you. So we label them. Equation 1 and equation 2. Okay, now I've got two variables, x and y. I need to get rid of one. So I need to either add or subtract, because I can see I've got one y here and one y here. Subtracting won't help me, because y minus minus y makes y plus y. So this time I'm going to add equation 1 and equation 2. So I'm going to add them. 2x plus x gives me 3x. Y plus minus y gives me 0, which is why I've added them, because the signs are different. And 21 plus 6 gives me 27. So if I'm going to take my 3 underneath the 27, because it's times here, so we divide on that side. So x on this side is going to be equal to 27 divided by 3, so x is going to be equal to 9. So I found one of my variables, which is great. So now I'm going to put it back into, let's go for equation 1, shall we? I always tend to use equation 1. I don't know why. So we say sub for x in equation 1. And so we got 2x plus y equals 21. I know x equals 9, so it'll be 2 times 9 plus y equals 21. So 18 plus y equals 21. So y is going to be equal to plus 18 on this side. When I float it over the other side, it comes minus 18. 21 minus 18, which is equal to 3. So that's my solution then. X equals 9 and y equals 3. So the solution is where this line and this line intersect, where they cross, if we were to draw them out. Okay, this example you need to put in your notes. So hit pause, write the example down. When you're ready, hit play and we'll go through another example. Hopefully it's all coming back to you. Right, let's have a look at this second example then. This time we've got to solve, again, the two straight lines. 6x plus y equals 20 and 3x plus y equals 11. So we've got to now, first things first, what did we say we always do first? Label the equations. Equation 1 and equation 2. Okay, so now we've got to decide how to get rid. I've got a 1y and 1y, so the y's are going to go. How do I get rid of them? Do I add or subtract? They've got the same sign, so this time I'm going to subtract. So subtract equation 2 from 1. So let's draw a line and subtract. 6x take away 3x gives me 3x. Y minus y gives me nothing, so I'm getting rid of the y. And 20 minus 11 gives me 9. Fantastic. So that means that the 3 goes down the escalator under the 9, so x is going to be equal to 9 divided by 3, so x is equal to 3. That's great, I've solved my x. So now, how do I get y? I sub it back into equation 1. It could be equation 2, it doesn't matter. So we say sub for x, because we know what x is, in equation 1. So equation 1 says 6x plus y equals 20, x equals 3, so 6 times 3 plus y equals 20. 6 times 3 is 18, plus y equals 20. Oops. So float and ping the 18 over the other side. We get y is equal to 20 minus 18, which is 2. Oops, y equals 2. So I've got my coordinates, x equals 3 and y equals 2. So that's where the two lines intersect. So 3 and 2. Good. Hit pause. Make some notes. Write the example down. When you're ready, hit play again. Okay. On this example, I quite like what they've done here. They've, instead of using x and y, which everybody feels too comfortable with, they've used p and q. So let's first things first. Let's label our equation. Equation 1 and equation 2. So we've got to get rid of p or q. Easiest to get rid of p's, okay, because we've got one p and one q. These have coefficients which are different numbers, so can't get rid of them. So how am I going to get rid of p's? They've got the same sign, so I'm going to subtract equation 2 from equation 1. So p minus p gives me 0. 6q minus 2q gives me 4q, which is equal to 17 minus 9, which is 8. The 4 goes down underneath the 8 because it's multiply here, so it's divide on the other side. It's the opposite sign. So q is going to be equal to 8 divided by 4, so q is equal to 2. And how am I going to find p? Anyone remember? Drag. We put the q, we sub it back in equation, I'm going for equation 1. Sub for q in equation 1. So that means we've got p plus 6q equals 17. So p plus 12 equals 17. So p is going to equal to 17 minus 12, which is equal to 5. So I've got p equals 5 and q is equal to 2. Hit pause, write this example down, and when you're ready, hit play again. Okay, so 4 quick questions for you. We haven't finished yet. We've got more examples to do after this, but 4 quick questions. So hit pause, attempt all 4, and when you're ready, hit play again, and we'll move on. And for these 4 questions, I want to see all the workings exactly as we've been doing them. Okay, label them, decide if you're going to add or subtract, and so on. So hit pause, when you're ready, hit play again. Okay, so it's time for you to mark your work. Green pens, as always. Question 1, you should have x equals 22 and y equals 8. Question 2, 3 and 5. Question 3, 5 and 3. And question 4, 2 and 3. So mark it, and when you're ready, hit play and we move on. Right, so this type of question is slightly different, only slightly different. This time, I can't either just add or subtract because I don't have the same coefficients in front of either the x or the y. So I've got to find a way of making sure I can do this. Now, first things first, always label equation 1, equation 2. Now, how can I make 2 of the coefficients the same? What I can do is I can multiply equation 2. I'll tell you what I'm going to do. I'm going to write it underneath it. Let me just rub that out. Get my pen back. Right, so I'm going to say multiply equation 2 by 4. Okay, so if I multiply equation 2 by 4, that means I multiply all the terms by 4. So 4 times 3x gives me 12x, minus 4y is equal to, and 4 times 7 gives me 28. This is a new equation, so I'm going to call it equation 3. And then I'm going to take my equation 1. So I can't use this equation because it's the same as this one. I've just multiplied it. I'm going to take that equation 1 here, which is 5x plus 4y equals 23. Can you now see why I multiplied it by 4? Because now I've got two 4's. Now I can eliminate the y. So tell me, am I going to add or subtract? The signs are different, so I'm going to add equation 3 and equation 1. So if I add them, 12x plus 5x gives me 17x, minus 4 plus 4 gives me 0, and 28 plus 23 gives me 51. Now 17x means 17 times x. It's times on this side, crosses equal sign becomes divide, so x is going to be equal to 51 divided by 17. So that means x is equal to 3. So I've got my x. How do I find y? So let's move on to this side of the page then. To find y, sub for x in equation, let's go for equation 2 this time, just to be different. So that means we've got 3x minus y equals 7. I know that x equals 3, so it'll be 3 times 3 minus y equals 7. 3 times 3 is 9 minus y equals 7. Because it's minus y, and I don't like having a negative y, I'm going to take the y over that side. Minus y becomes plus y on the other side. At the same time, I'm going to bring my plus 7 over the equal sign to this side. It becomes minus 7. Just go back to a red pen. Oops, I've got a yellow pen now. There. So that means I've got 9 minus 7 is equal to y. So 2 equals y, or y equals 2. So solved it. X equals 3, y equals 2. Those are my two solutions. Or my solution, my coordinates for where these two lines intersect. So hit pause, make some notes on that. And when you're ready, hit play again. We'll look at another example. Okay, this example, first things first, always label equation 1, equation 2. Again, I've got a problem. I've got 7 and 2 and 3 and 1. How can I make the coefficients the same this time? I can multiply equation 2 by 3. So that means I've got 7x plus 3y equals 56. That's equation 1. And then I've got to multiply this equation by 3. So I'll multiply everything by 3. 3 times 2x gives me 6x. 3 times y is plus 3y. And 3 times 17 is 51. It's a new equation, so I'll call it equation 3. Okay. Now my y's are the same, 3y and 3y. How do I get rid of them? Signs are the same, so I subtract. Equation 3 from equation 1. So let's do that then. So 7x minus 6x gives me x. 3y minus 3y is nothing. and 56 minus 51 is 5. So x equals 5. How do I get y? So I'll substitute. Let's write it in full. For x in equation, go on, let's go for equation 1. It's my usual. So I've got equation 1 is 7x plus 3y equals 56. So it'll be 7 times 5 plus 3y equals 56. 35 plus 3y equals 56. So if it's 35 on this side, plus 35, when we move it across the equal sign, because minus 35. So 3y is equal to 56 minus 35. 3y equals 21. And so what, dividing by 7, let's go up here. So it says 3y equals 21. The 3 goes down the escalator under the 21, so y is going to be equal to 21 over 3, y equals 7. Okay? Because it's 3 times y on this side, so it's going to be divided on that side. So we've got our coordinates, x equals 5, y equals 7. Hit pause. Make your notes. When you're ready, hit play again. Okay, so for this example, simultaneous equations, P and Q, so 2 variables, but you've got 2 equations, so we can get rid of either P or Q. Oops. I'm going to label this 1, label this one 2. So what can I do to make the coefficients the same? What do you think? I'm going for a shorter sort of cut on this one. I'm going to multiply this equation by 3. Okay, so times this equation by 3. I tell you what, let's write it in full. Otherwise we'll get bad habits forming, and we don't want to do that while you're not in class. So let's go back to the red pen. So we'll say multiply equation 2 by 3. If I do that, I've got to multiply all the terms by 3. So that means I've got 3 times p is 3p plus 5 times 3, 15q is equal to 19 times 3, which is 57. And that's a new equation, so we'll call that equation 3. And equation 1 is 3p plus 4q equals 24, equation 1. Okay. Now I've got 3p and 3p. They've got the same sign, so this time I'm going to subtract equation 1 from equation 3. So let's do that. Draw a line under it. 3p minus 3p is nothing. 15q minus 4q is 11q. And 57 minus 24 is 33. So we can take the 11, just times q, and make it divide on the other side. Q is equal to 33 divided by 11. So q is equal to 3. Let's draw a line, and then we can find p. So we can say sub for q in equation 1. So equation 1 is 3p plus 4q equals 24. We know that q is 3, so 3p plus 4 times 3 equals 24. 3p plus 12 is 24, so 3p equals 24. Plus 12 floats over the other side, becomes minus on the other side. Okay, so 3p equals 24 minus 12, which is 12, and so p, the 3 goes down the escalator under the 12 over 3, so p equals 4. Okay, so my coordinates are P equals 4 and Q is equal to 3. Okay, so I want you to write this example down. So hit pause, copy the example down, and when you're ready to, when you're finished, hit play again, and you can do some questions for me. Good. Okay, so 4 quick questions for you to do before I give you my exercise. So hit pause, have a go at all 4 of them, and I want to see your full workings. Post them on Teams later. So hit pause, full workings, label them, decide if you're going to which one you're going to multiply, and so on. Okay, good. Right then, let's have a look at the answers to these then. Question 1, you should have x equals 4 and y equals 5. Question 2, 1 and 1. Question 3, 10 and 9. And question 4, you should have 9 and 1. Okay. Okay, so you got 12 questions to go. So you can do them from here. I'm going to attach them also as a worksheet. So good luck, enjoy.